Problem number 12 is a Taylor series polynomial question. It gives you a function, square root of 1 plus x, centered around a equals 3, and it wants you to find the second degree Taylor polynomial to approximate square root of 4.4. So if we're only trying to find the second degree polynomial, I'm not actually going to go through the entire derivation for finding the nth summation term for the Taylor series. I'm only going to derive out my n equals 0, 1, and 2 terms and see if I can get the approximation for this. So when I go ahead and make my chart, I have an n column, an fn of x column, and an fn of 3 column. This is n equals 0, 1, and 2. So again, I'm going to stop here because I only want second order. I don't want the entire thing, so I don't need to find an infinite series representation for it. So this is going to be 1 plus x to the 1/2. If I plug in my center at a equals 3, I end up with 4 to the 1/2, which is 2. So my first coefficient is 2. If I take the derivative, I end up with 1/2, 1 plus x to the negative 1/2. If I go ahead and plug in my center, I end up with 1/2 times 1 over square root of 4. So that would be 1/4. If I take the derivative one more time, I end up with 1/2, negative 1/2, 1 plus x to the negative 3 over 2. And keep in mind also, be wary of chain rule. In this case, the chain rule, the derivation of the inside is just 1, so I don't need to multiply by anything. But if this was like 3x, I might have to carry something over. So if I go ahead and plug into this, I end up with 1/2 times negative 1/2 times 1 over 4 to the 3/2, which would be 1 over 2 cubed, so that simplifies to 1 over 8. So this coefficient here would be minus 1 over, and that would be 8 times 2 is 16, 16 times 2 is 32. So minus 1 over 32. Okay, great. So now I can go ahead and expand out my Taylor series. Again, I'm only going to my n equals 2 term, not going to go any further. So f of x is approximately equal to, so I plug in my n equals 0, I have 2x minus 0, or sorry, x minus 3 to the 0 over 0 factorial. That's the first term in my series. Next term would be 1/4 x minus 3 to the first power over 1 factorial. And then I have minus 1 over 32 x minus 3 quantity squared over 2 factorial. So this is the Taylor series I'm going to use. 1, 2, 3 terms. I'm at my second degree. That's exactly where I want to be. So if this had said third degree, we would go one more term until we reached a power of n equals 3. So now I'm going to clear myself a little bit of room, and we have to get the approximation for square root of 4.4. So if you look at your answers in the test, they're all decimals, which means that we are going to have to do a distinct amount of math in this case. So let's go through and let's try to do this carefully. So first off, I need to figure out what x value I'm going to plug into here. So I take my function and equate it with my required value in this case, which I need to approximate square root of 4.4. If I go through and solve for x, I end up getting x equals 3.4. And that would be if I square both sides and subtract off the 1, x is equal to 3.4. So now I'm going to plug into my Taylor series approximation with 3.4, and that is roughly equal to, first value is just 2, because x minus 3 to the 0 over 0 factorial is just 1. Next term would be plus 1/4 times 3.4 minus 3 to the first power over 1 factorial. 1 factorial is just 1. Minus 1 over 32 times 1 over 2 factorial is minus 1 over 64. X minus 3 quantity squared, so that'd be 3.4 minus 3 quantity squared. Okay, so now I have this term, so all I need to do is I need to figure out how to simplify it into decimal form. So I'm just going to take one term at a time. So my first term is just 2. Can't really do anything with that. Just going to leave it as 2 because the first digit is actually 2 for all the answers. So we do know that we're at least on the right track. So I have a 2. I have plus, so this is 0.4 times 1/4, so I have 1/4, and then the 3.4 minus 3 yields a 0.4. 0.4 is equal to 4/10. So I'm just going to write that as that for now. In my next term, I have 1/64, and I have 3.4 minus 3, which I already know is 4/10. So this would be 4/10 squared, which if I square that, that ends up being 16/100. Okay, so now I'm just going to rewrite a little bit. This 1/4 and this 4 can cancel, so I'm left with a 1/10. 1/10 in decimal form is 0.1, so I'm going to write 0.1 for this term. And now for here, this is going to get a little bit tricky. I have 16/64. That does go into 64 4 times. So I have a 1/4 times 1/100. Now 1/100 is 0.01. So I could write this as 0.25, which would be the 1/4 that I have left over, and the 1/100 is 0.01. Now, the key here is we just need to figure out what this should be. We need to figure out what 0.25 times 0.01 should be. So, if I think back to multiplying decimals, whenever I multiply this through, I would move it back. So what I end up getting is 0.01 times 0.25 is actually equal to 0.0025. Good. 2 plus 0.1 minus 0.0025. Now I can do this subtraction. I have 0.1 minus 0.0025. If I subtract off that value, I end up getting 2 plus 0.0975. Which makes sense because if I add this back into this, 0.0975 plus 0.0025, that ends up right back at 0.1. So my final answer is that the approximation for square root of 4.4 with a second degree Taylor polynomial centered at 3 is 2.0975. Which leaves my answer in the answer key to be D. So D is my final answer.
The Teaching Center, UF's Learning Resource Center.